Hello again, everyone. Dr. Tom McNamara back for our course in Prep for College Math. We are going to move on in our class to dealing with the integers. So these first couple videos, or this first video, will be about an intro to the integers. So up to this point in our class, we have been dealing with the whole numbers, which start with 0 and then continue on forever, right? That's what these dots indicate. Dot, dot, dot. That pattern continues forever. So every whole number is an integer. So the integers are a bigger set of numbers. The integers also contain negatives. So it's almost like the integers kind of continue in both directions. So the set of whole numbers has a smallest element, namely the element 0. The set of integers does not have a smallest element. If we were to plot these on a number line here, zeros right there. Our positives are over here on the right. And then we keep on going that way. Our negatives are over here on the left. So you can keep on going further left. And of course, on the number line, if you're moving to the right, those are larger numbers. If you're moving to the left, those are smaller numbers on your number line. Okay, so every positive number is larger than any negative number. Okay, so if we were to do some inequalities here with negatives, just to kind of get our feet wet. So we will insert either less than or greater than to make a true statement. Okay, so we will insert either less than or greater than to make a true statement. So let me look at a few here. Let's do okay. How about 6 and negative 6? Okay, so as we were discussing up here, numbers to the right are larger than numbers to the left. So we can see here, positive 6 would be to the right of negative 6, which would be way over there. Okay, so the appropriate inequality symbol would be that. 6 is greater than negative 6. Let me look at this here. Negative 11 compared to negative 10. Okay, negative 11 is actually less than negative 10. If you don't believe me, plot it on the number line. We would continue up here, right? Negative 6, negative 7, negative 8, negative 9, negative 10, negative 11. So negative 11, if we continued this number line, would be to the left of negative 10. Okay, so when we extend our domain to the integers, we have introduced these negative numbers. And there are some important uses for negative numbers. Negative numbers can be useful for representing debts. You use your positive numbers to represent assets, and negative numbers to represent your debts or liabilities. For example, depth below a surface. So if I, let's say, had, I'll do my best to do a little bit of water here. So we might indicate water, the surface of water is 0, and your height above would be your positives, your depth below would be your negatives. So 1 foot below would be like a height of -1. This also works out for temperature. Negative numbers are useful in dealing with temperature. 0 on the Celsius scale is the temperature at which water freezes. A negative temperature would indicate it's even colder than that. Okay, so plenty of uses for negative numbers, and we'll look at quite a few as we go through this section here. And when we introduce the negative numbers, we also introduce a new operation. And that operation is taking the opposite. Okay, so we already had 4 operations that we could do with numbers: addition, subtraction, multiplication, and division. Now we have a new one, taking the opposite. So let's look at a couple of examples here. We'll look at a number and we'll look at its opposite. Okay, so let's look at, say, a positive number. The opposite of 39 would be negative 39. If we look at a number like negative 25, the opposite of negative 25 would be 25. If we looked at 0, 0 would be its own opposite. Okay, so on your number line, you have 0 right there in the middle, and then you have your positives over here, and your negatives over here. And when you're taking the opposite, you're basically switching sides. Okay, if you start in the negatives and you take the opposite, you end up with the positives. If you start with the positives, you end up with the negatives. But 0 is kind of this little special point in the middle. Okay, so a couple of other examples I want to do here. Let's do this example. Let's graph some points on a number line. Which points do I want to do? Okay, so graph 4, negative 4, negative 2, 1, and 3 on a number line. Okay, so I'll start with my number line there. I will designate a point 0. Make tick marks. Okay, so to say plot something on a number line, we're just going to put a dot. So negative 2 is over here. Okay, so that's negative 1, negative 2, negative 3, negative 4. Negative 4 right there, positive 3 right there. Okay. So graphing on a number line, really easy to do. Just remember, you, of course, can extend both ways, and the negatives are over to the left, the positives are always to the right of 0. Okay, now, one other thing that we need to talk about when we are introducing the integers is the concept of absolute value, the absolute value of a number. The absolute value of a number is its distance from 0. Okay, so the absolute value of a number is its distance from 0. So if I were to go back up here to my little table, I could talk about the absolute value of each of these numbers. So 39, its opposite is negative 39. Now if I were to plot 39 on a number line, it'd be a little tedious. I'd have to extend it way out, but I would be 39 units away from 0 to the right. Okay, here I'm talking about the absolute value of this, but that's also the absolute value of this number. This is 39 units to the right of 0. This is 39 units to the left of 0. They both have absolute value 39. If I'm talking about negative 25, that would be 25 units away from 0, 25 units to the left of 0. This is 25 units to the right of 0. So both of them have absolute value 25. If I talk about the absolute value of 0, that is 0. Remember, absolute value is the distance of a number from 0. So 0 isn't any distance from 0. It's at 0 already. Okay. So let's do a few example operations with absolute value. Yeah, let's do them right here. So evaluate each. Now let me pick some good ones here. Okay, some expressions that involve absolute value. So we're talking like over here. And maybe some that have a couple like negatives in there and things like that. Okay, so if I were to do, let's say, absolute value 9, okay, that is 9. Absolute value -8 is 8. Okay. One quick thing here. Absolute value will never give a negative output. Okay, if we consider the process of taking the absolute value of a number, we will never get a negative number for the output of the absolute value. So for example here, absolute negative 114, 114. Okay. So let me do a couple more that involve some negative signs and absolute value in different combinations here. So let's do let's say the instructions here are simplify each. Okay. So when you see a negative out here like this, I want you to think opposite. So this is the opposite of whatever comes next. So the opposite of -11, well, that would be 11. Okay. This new operation of taking the opposite is something that actually undoes itself. Right? You could think of this -11 as the opposite of 11, and then you're doing the opposite of that. So you've done the opposite twice. So you end up right back where you started. Okay. Similar example here, opposite of -4. So this little note applies right there. The opposite of -4 is 4. The opposite of the absolute value of 20 is -20. Okay, now you might be saying, okay, Dr. Mack, you just said absolute value will never give you a negative output. And now you wrote this. Well, what I said was true here, right? The absolute value did not give us a negative output. This piece of instruction is what gave us the negative output. So we're dealing here first. Take the absolute value of 20. When I do that, I get 20. And then over here, we're doing the opposite. So I'm actually going to write down our thinking on that here. So we take the absolute value of 20. We get 20. Then we take the opposite of 20, which is -20. Okay, let's do one kind of like this. Let's do negative of the absolute value of -253. Okay, so once again, we're dealing with this absolute value first. we're doing opposite eventually. The opposite of what? Well, it's the opposite of the absolute value of negative 253. So the first thing I have to do is take the absolute value of negative 253. When I do that, I get 253. And the instructions say take the opposite of that. Okay? So it's not like anytime you see an absolute value, all the negatives in your problem will vanish. It depends on where they are. If the absolute value is having a negative inside it, then the absolute value gets rid of it. If there's a negative outside of it, that's going to stick around. Okay, let's do kind of a one that combines doing inequalities and absolute value. So put that or that, put less than or greater than to make a true statement. And let's do a few here. Let's do absolute value of negative 12, and we're comparing that to the opposite of negative 7. Okay. So, what we should do before we decide what we're going to put in the middle here is we should simplify these expressions here. Okay? We're taking the absolute value of negative 12. So, this is a 12. And here we're taking the opposite of negative 7. The opposite of negative 7 is positive 7, so we should put a greater than symbol right there. Negative of the absolute value of negative 71, and we'll compare that to negative of the absolute value of negative 65. Okay, let's see what we get here. So, absolute value of negative 71 is 71, and then we have a second negative. So what we end up with there is negative 71. Down here, negative 65. Now you got to remember the negative numbers are kind of ordered backwards. Okay, if I were to plot these, I would hit negative 65 and then negative 66, negative 67, negative 68, negative 69, negative 70, negative 71. It would be way to the left of negative 65. So negative 71 is less than negative 65. You got to remember that ordering of negative numbers goes backwards. Okay, so I will scan these notes. I'll put a link to them in our Canvas course. This should give you enough examples to understand how to work out the assigned problems for homework 2.1.